A sphere has a radius of 10 centimeters. If the radius is increased by 2%, find the approximate increase in the area. So, what is the area of a sphere? The area of a sphere is given by A equals 4 pi r squared. But now, we're given the radius. The radius is equal to 10 centimeters. So we are supposed to find the approximate increase in area. So we know that the increase in area, delta A, we reference to the increase in radius, delta R, approaches the A, the R. So from here, we can make the increase in the area the subject. So if we multiply both sides by delta R and this side too by delta R, see that this delta R and this delta R can cancel out. So the increase in area is given by the A, the R, times the change or the increase in the radius. But now, from the question, the radius was increased by 2%. This means that delta R is equal to 2% is the same as 2 divided by 100 times the radius. And this is equal to 0.02 R. But from the question, the value of the radius was given. So now let's find the ADR. The area A is giving us 4 pi r squared. What is the A, the R? So 2 will come down to multiply 4. It's 4 times 2. Then we will be left with pi r. Then 2 minus 1 will give it 1. So the ADR is equal to 8 pi r. So from here we can find the increase in area. So the increase in area delta A is equal to the ADR, which is 8 pi r, then times delta R, times, but delta R is 0.02 r, 0.02 r. So this is equal to 8 times 0.02 in one bracket, then pi r squared. But we were given the value of r, the radius as 10 centimeters. So this is equal to 8 times 0.02 times pi times the radius, which is 10 squared. And this is equal to 8 times 0.02, then 10 squared is 100 times 100 times pi. 0.02 times 100 is 2. 2 times 8 is 16. So this is equal to 16 pi centimeter squared. An object is thrown into the air such that its height, h meters, after time t seconds, is given by h equals 36 minus 40 squared. Find A, the velocity at time t equals 0, and B, the time taken to reach the maximum height. So we're giving h the height as 36t minus 4t squared. What is the velocity? Velocity is equal to dh dt, because velocity is equal to distance over time. So dh dt is can also be written as h prime of t. So let's go ahead and find h prime of t. So h of t is equal to 36t minus 4t squared. So h prime of t is equal to, if you differentiate 36t, you will get 36 minus, if you differentiate 4t squared, you will get 8t. So h prime of t is equal to 36 minus ht. But the question says that we should find the velocity at time t equals 0. So that means that wherever we see t in this equation, we need to insert 0, which is the same as finding h prime of 0. And this is equal to 36 minus 8 times 0. So this is equal to 36 minus 8 times 0 is 0, and that is equal to 36 centimeters per second. Then the second part of the question says we should find the time taken to reach the maximum height. So now, the time taken to reach at the maximum height, h prime of t is equal to 0. So what we need to do is to take h prime of t, which is this equation, and equate it to 0, and we can find the value of t. So 36 minus 8t is equal to 0. This implies that 8t is equal to 36. So let's divide through by 8. What is the value of t? T is equal to 36 divided by 8. And 36 divided by 8 is 4.5 seconds. Find the equation of the tangent to the curve y equals x into bracket x squared minus 12 at the point where x is equal to 3. So y is equal to x into bracket x squared minus 12. But we know the x component, which is x is equal to 3 at that point. So what we need to do is to find the y component so that we can know the point. So we need to find y of 3. Y of 3, so wherever we see x, we insert 3. So this becomes 3 times into bracket 3 squared minus 12. This is equal to 3 times 3 squared is 9 minus 12. This is equal to 3 times 9 minus 12 is minus 3. And 3 times minus 3 is minus 9. And therefore the point at which the tangent touches the curve is equal to the x component is 3 and the y component is minus 9. So having found the point, the next thing we need to do is to find the gradient. We know that from the question y is given as y equals x times x squared minus 12. So we need to find the gradient m. We know that the gradient m is equal to dy dx. And this dy dx can also be written as y prime of x. So let's find y prime of x. So y prime of x is equal to, we need to differentiate this function. Remember, let me write it down here before I come to the y prime of x. Let me write it at the top. For example, if we have a function f of x equals the product of two functions g of x times h of x, you will see that f prime of x is, you will take this function g of x and you differentiate it, you get g prime of x, then you maintain h of x, then you add it to, you maintain this function which is g of x, and then you differentiate the h of x function, it will give you h prime of x. So let's do that. So in this case, g of x is x and h of x is into bracket x squared minus 12. So the first part, differentiate g of x. If you differentiate x, you will get 1 and maintain h of x. 1 times into bracket x squared minus 12 will give, so this is 1 times x squared minus 12 plus, maintain g of x. G of x is x, and multiply by the differential of h prime of x. If you differentiate x squared minus 12, you will get 2x. So y prime of x is equal to x squared minus 12 plus x times 2x is 2x squared. So y prime of x is equal to x squared plus 2x is 3x squared. X squared plus 2x squared is 3x squared. So this is 3x squared minus 12. Then now, having found y prime, which is the gradient, we need to find the value by finding y prime of 3, because from the question, the tangent touches the curve at x equals 3. So what is y prime of 3? That is equal to, wherever you see x, you insert 3 into the equation. So this is equal to 3 times 3 squared minus 12. This is equal to 3 times 3 squared is 9 minus 12. And this is equal to 3 times 9 is 27. 27 minus 12. So what is 27 minus 12? The answer is 15. So therefore, y prime of 3 is equal to 15. But remember that we've already said y prime is m, and m is the gradient. So this implies that the gradient m is equal to 15. So we are now in a good position to find the equation of the tangent. Remember that we have the point 3 minus 9, and we have the gradient m equals 15. Equation of a straight line is given as y minus y1 equals m, the gradient, into bracket x minus x1. So y minus y1 is minus 9 equals m is 15 times x minus x1 is 3. So y minus 9 is y plus 9 equals 15 times x minus 15 times 3, which is 45. 15 times x is 15x. So this is equal to, I'm taking all of these terms to the left hand side of the equation. It will give us y minus 15x, then plus 9 plus 45 is equal to 0. So y minus 15x, then 9 plus 45 is 54. So plus 54 is equal to 0. The side of a cube increases by 5%. Find the corresponding percentage increase in volume. So first, what is the formula for the volume of a cube? V is equal to the side, which is L cube. Then the question says that side increases by 5%. It means that the increase in length is equal to 5 divided by 100 times the original length L. And then this is equal to 0.05 L. Then now, the question is asking us to find the corresponding percentage increase in volume. So what we must first find is to find the increase in volume before we can then go ahead to find the percentage increase in volume. But we know that the increase in volume, delta V, we reference to the increase in length, delta L, approaches dv dl. So the increase in volume, delta V, is equal to dv dl times delta L. So now, let's find dv dl. What is dv dl? Let me solve it. Let me continue from here. So dv dl is equal to, we are supposed to differentiate L cube, and that will give 3L squared. So dv dl is 3L squared. So we'll then take this dv dl and put it in this equation to find delta V. So delta V is equal to dv dl, which is 3L squared, times delta L, and delta L is times 0.05 L, because delta L is 0.05 L. So delta V is equal to, in one bracket 3 times 0.05, then times L squared times L equals L cubed. But the question says we should find the percentage increase in volume. But we know that the percentage increase in the volume is equal to the increase in volume over the original volume times 100%. So the percentage increase in volume, delta V, equals the increase in volume, delta V, which is what we found earlier, 3 times 0.05 L cubed divided by the original volume. The original volume is given as L cubed times 100%. So that this L cube and L cube can cancel. So at the end of the day, the percentage increase in volume, delta V, equals 3 times 0.05 times 100%. And this is equal to 15%. Now, one trick for knowing whether you are right, anytime you are asked to find the percentage increase in either the area or the volume, just multiply the exponent of the formula 3 by the percentage increase that was given. So in this case, it's 3 times 5%, and this is equal to 15%, and that is the very answer we got. So this is one easy way of checking the percentage increase in volume. A ball is thrown vertically upwards. Its height, h in meters, at time t is given by h equals 5 plus 30t minus 5t squared. Find A, the velocity of the ball at time t equals 2 seconds, and B, the maximum height reached. So the equation is the height, and the height is given as h equals 5 plus 30t minus 5t squared. So the first part is we should find the velocity of the ball. We know that the velocity of the ball is equal to dh dt, and this can also be written as v prime of t. So the velocity h prime of t, made a mistake. So let's find h prime of t. H of t equals 5 plus 30t minus 5t squared. What is h prime of t? It is equal to, if you differentiate 5, you get 0. And if you differentiate 30t, you will get 30 minus, if you differentiate 5t squared, is 10t. So h prime of t, the velocity of the ball, is 30 minus 10t. However, he said we should find it at 2 seconds. So we need to find h prime of 2 because t is equal to 2 seconds. And that is equal to 30 minus 10 times 2. And this is equal to 30 minus 20. And this is equal to 10 seconds. So the velocity of the ball at t equals 2 seconds is 10 seconds. Then the B part says we should find the maximum height reached. We will not know the maximum height except we find the time at which the maximum height is reached. So the first thing is to find the time at which the maximum height is reached. But we know that at the maximum height, h prime of t, which is the velocity, is equal to 0. So this means that we just have to take h prime of t and equate it to 0. So this implies that 30 minus 10t is equal to 0. So 10t is equal to 30. So let's divide through by 10. This 10 and this 10 cancel. So t is equal to 30 divided by 10 is 3 seconds. So at the maximum height, the time is 3 seconds. So we then have to take this t equals 3 seconds and put it back into the original equation of the height and then find the maximum height. So that is just equivalent to finding h of 3, and that is equal to 5 plus 30t, which is 30 times 3, minus 5 times 5t squared, which is 5 times 3 squared. So h of 3 is equal to 5 plus 30 times 3 is 90, minus 3 squared is 9, times 5 is 45. So h of 3 is equal to 5 plus 90 is 95, minus 45. So h of 3 equals 95 minus 45 is 50 meters. Let y equals x cubed minus x squared minus 9x plus 9 be the equation of a curve. I. Determine the intercept the curve makes with the coordinate axis. I. Find the turning points of the curve, distinguishing between them. And then the last part is sketch the curve. So the curve is y equals x cubed minus x squared minus 9x plus 9. So it says that we should determine the intercept the curve makes with the coordinate axis. So let's first find the y-intercept. What is the y-intercept of this equation? We know that the y-intercept x is equal to 0. So we just have to find y of 0. And that is equal to 0 cubed minus 0 squared minus 9 times 0 plus 9. So y of 0 equals, all of this will go to 0. It's just equal to 9. So we have one of the points at the intercept is 0, 9. So having found the y-intercept, let's go ahead and find the x-intercept. So x-intercept. For the x-intercept, y equals 0. So we need to take x cubed minus x squared minus 9x plus 9 is equal to 0. So how do we find the values of x? Let's try x equals 1 and see if we put 1 into this equation, what will we get? It will be 1 cubed minus 1 squared minus 9 times 1 plus 9. 1 cubed is 1, minus 1 squared is also 1. 1 minus 1 is 0. 9 minus 9 times 1 is minus 9, plus 9 is also 0. So this is equal to 0. Now this implies that x minus 1 is a factor. It's a factor of this polynomial y. So what we will then do is that we will then take this polynomial and divide it by x minus 1. So let's continue from this side. So let's do the division here. So we have x minus 1, and then we have x cubed minus x squared minus 9x plus 9. So x cubed divided by x is x squared. So x squared times x is x cubed. Then x squared times minus 1 is minus x squared. When you subtract, this side goes to 0. So we are left with minus 9x plus 9. Minus 9x divided by x is minus 9. Minus 9 times x is minus 9x. Minus 9 times minus 1 is plus 9. So if you do this subtraction, we'll get 0. So it means that the factors are x minus 1 in one bracket, and in another bracket x squared minus 9 equals 0. I will know that this can also be written as, in one bracket, x minus 1. In another bracket, x squared minus 3 squared equals 0. And this is just difference of two squares. So the factors are x minus 1 times x minus 3 in one bracket times x plus 3 is equal to 0. So the values of x are x equals minus 3, x equals 1, and x equals 3. So these are the x-intercepts of the curve. So this means that we have the point minus 3, 0. Then we also have the point 1, 0. And then we have the point 3, 0 on this curve. It is to find the turning points of the curve and distinguish between them. We know that the curve is given as y equals x cubed minus x squared minus 9x plus 9. So in order to find the turning points, we need to find y prime of x and equate it to 0. So what is y prime of x? Differentiate this function. This is equal to, if you differentiate x cubed, we'll get 3x squared. You differentiate minus x squared, it gives minus 2x. And if you differentiate minus 9x, it is minus 9. So let's take this and equate to 0. So 3x squared minus 2x minus 9 equals 0. 3 times minus 9, if we go by that route, we will not get straight factors. So let's use the quadratic formula. So you see that this is of the form ax squared plus bx plus c equals 0. So you can see that from here, a is equal to 3, b is equal to minus 2, and then c is equal to minus 9. So the quadratic formula, x is equal to minus b plus or minus square root of b squared minus 4ac, all of that divided by 2a. So x is equal to minus b, which is minus 2, and that will give us plus 2, plus or minus square root of b squared. B squared is minus 2 squared minus 4ac. 4 times a is 3 times c, which is minus 9, all divided by 2a. 2 times is 3. So x is equal to, let me continue from here. So x is equal to 2 plus or minus square root of minus 2 squared is 4. And then minus 4 times 3 times minus 9 will give 108. All of that divided by, so this is plus or minus, all of that divided by 2 times 3, which is 6. So further simplification, x is equal to 2 plus or minus. So further simplification, x is equal to 2 divided by 3 is 2 divided by 6 is 0.33. Then when you solve all of this in the bracket, you get plus or minus 1.76. So the values of x is equal to 0.33 minus 1.76 is equal to minus 1.4. And then 0.33 plus 1.76 is equal to 2.1. So x is also equal to 2.1. So these are the values of x. Having found the values of x, we have to take these values and put it back in the original equation of y to find the corresponding values of y. So let's find y of 2.1. It is equal to 2.1 cubed minus 2.1 squared minus 9 times 2.1 plus 9. So this is equal to minus 5.1. Let's also go ahead and find y of minus 1.4. And this is equal to minus 1.4 cubed minus 1.4 squared minus 9 times minus 1.4 plus 9. And this is equal to 16 16.9. So the turning point. We have one of those points as 2.1 and then 5 minus 5.1. This is one of the turning points, and the second one is minus 1.4 and then 16.9. So the question says we should distinguish between those 2 points. We can only distinguish between these 2 points by finding the second derivative, which is y prime prime. And we know that if y prime prime, the second derivative, is less than 0, we have a maximum point. And then if the second derivative, y prime prime, is greater than 0, then we have a minimum point at that point. So let's find y prime prime from this equation. Y prime prime is equal to, if you differentiate 3x squared, you will get 6x. If you differentiate minus 2x, you get minus 2. And if you differentiate minus 9, is 0. So y prime prime of x, which is the second derivative, is 6x minus 2. So we need to then find y prime prime of 2.1. And this is equal to 6 times 2.1 minus 2. And that will give us 10.6. So 10.6 is greater than 0. It means that this point, 2, 1, and minus 5.1, this is a minimum point. Minimum point. Let's also find y prime prime of minus 1.4. This is equal to 6 times minus 1.4 minus 2. And that is equal to minus 10.4. So it means that this point, minus 10.4, is less than 0. So this point, minus 1.4 and 16.9, is a maximum point. So the last part of the question says we should sketch the curve. So we have the points 0, 9, and we also have the point minus 3, 0, then 1, 0, and then 3, 0. Then for the turning point, we have 2.1 and minus 5.1. Then the second turning point is minus 1.4 and then 16.9. So having found this point, let's go ahead and sketch the graph. So this is the Cartesian plane of our graph. Let's then go ahead and plot the points. So we have minus 3, 0. This is the point minus 3, 0. We also have the point 1, 0. This is 1, 0. And we have 3, 0. This is 3, 0. And this point is 2.1 and minus 5.1. So we have 2.1 is a little greater than 2. And then minus 5.1. So this is 10. Half of 10 is 5. So minus 5.1 is a little bit just above half. So the point will be somewhere here. The point is somewhere here. So this is the point, 2.1 and minus 5.1. And we also have this point, which is minus 1.4. So minus 1.4 somewhere here, and then 16.9. 10 and 20, half of that is 5. 5 plus 10 is 15. So half of this line is somewhere here. 16.9 is just above, a little above that point, somewhere here. And then 1.4, this is 1.5, so 1.4 is somewhere here. So we can plot this point as minus 1.4 and 16.9. My graph has not been drawn to scale. So if you use the original grade sheet, you should get everything correct. And so let's join the point. But there is this point here which is 0, 9. So we need to sketch the point 0. This is 10. 0, 9 is somewhere here. So this is the point 0, 9. So let's then go ahead and then join the points. So, but remember we said this point 2.1 minus 1.5 is the minimum point. So this is a minimum point and this is a maximum point. So we can then go ahead and then draw our curve. So our curve is going to look like this. And then this one falls off. 2 minus 3 and 0. So this is the nature of the graph that we are going to get. So let me then go ahead and join the various dots. So this is the nature of the graph that we are going to get.